Okay, so here's the problem we left off at. I asked you to stop and try to solve the problem in the same way we did before. Again, you're going to want to use u substitution. You have a sine squared theta and you have a sine theta, which plus you have a third term. So beware when you see this. You should automatically think u substitution because it sets up for a quadratic. Meaning you have a squared term, you have a variable term, and then you have a constant. So it's kind of setting you up for that. So again, we're going to use u substitution here. And what would u be? Hopefully you figured out that u would be sine theta. Alright, so we're going to have 2 times u squared plus 9 times u plus 7. Notice right away it's quadratic, right? So you're going to use the quadratic formula to solve. Quadratic formula. Again, I'm going to pause and I'm going to solve it and just put the answers down. If you need help with using the quadratic formula, just let me know. But for now, I'm just going to pause. Okay, so the two answers that I got was u is equal to -1 and u is equal to -3.5. So hopefully you got those two. Now we're just going to replace u back with sine theta. And sine theta. So if you notice, sine theta is never going to be -3.5, so we cannot get an answer for this particular one, so we just say that's not possible. Whereas sine theta -1, remember that's only in one spot, so sine theta is -1 here at 3 pi over 2. So on this particular problem, I believe there's only one answer, and that would be 3 pi over 2. Alright, so next problem. Similarly, we're going to solve this the same way. Technically, we want everything to be in cosine or everything to be in sine before we use that the u substitution method. And just know that cosine negative theta is the same thing as cosine theta. So every negative radian at cosine you find, there's also a corresponding positive one. So that means that we can go this way for positive angles and that way for negative angles. But in this situation, notice since it's a circular function, right, these same values occur for cosine going in the positive angle direction and the negative angle direction. So this would be positive 30 degrees and this would be negative 30 degrees, or it would be positive 330 degrees if you're going around the circle. So it depends on how you're going around the circle. So if you're going around the circle like this, all the degrees are positive, and your answer here would be positive 330. If you are going around the other way, then all of your angles are negative, but they wouldn't be those same values. It would be 30, 45, 60, negative 30 degrees, negative 45, negative 60. But if you notice, positive 30 degrees is square root of 3 over 2, but so is negative 30 degrees. So cosine and cosine theta and cosine negative theta are similar functions, and therefore we can use them as sort of the same. Alright, so let me resolve this and go back. So that doesn't throw off this problem at all, although you'd think it would, but it's not. Again, right when you see sine squared theta and you have cosine, well, you got to put it in one or the other. So I think it's better to put it in cosine since we already have the cosine. Here, sine squared we know is 1 minus cosine squared theta. Again, using that really quickly, again, using cosine squared theta plus sine squared theta equals 1. Using this identity, we just solve for sine squared theta. So we solve this for sine squared theta. We move that over to the other side, so it's going to be 1 minus cosine squared theta. Just a quick reminder. Alright, so now we have, this doesn't really matter how you do it, but 3 cosine theta plus 3. So I just distributed the 3 through here. Not a big deal. So we're going to clearly use u to be cosine theta. So it's going to be 1 minus u squared equals 3u plus 3. Now, again, remember I said that cosine negative theta has the same values as cosine theta. So we can just use it interchangeably. Okay, so now, again, if you notice, we have a quadratic. So what we're going to do is bring everything over to that side, bring all this over to that side so that it's positive. So on this side we have 0, on this side we have u squared plus 3u, and we're going to subtract that 1, so it's going to be plus 2. Again, use the quadratic formula. You're going to get 2 answers for u. I'm going to get those in a second. Alright, so the answers I got were -1 and -2. Again, it's cosine theta. So cosine theta is equal to -1. Cosine theta is equal to -2. Alright, so looking at our unit circle, cosine equal to -1 would be here. Cosine is -1 at pi. And that's it. So our answer here would be pi. Cosine is never going to be -2. So this answer is not possible. So you only have one answer, that's pi. Okay, so let me see what the next problem is. Okay, so this problem is a little bit trickier, and let me just say you're better off being in sine and cosine than you are being in tangent or secant. So really quickly I'm going to set this up before we have to stop this video. So remember, tangent theta is equal to sine theta over cosine theta. Don't forget that, that's important. So you could do the same thing with tangent squared. So tangent squared is equal to sine squared theta over cosine squared theta. And then if you know your trig functions, you would know that secant theta is equal to 1 over cosine theta. So this would be 1 over cosine theta. Okay, and you're multiplying those two things together. Alright, so here's kind of the setup, and again I'm going to have to stop this video and make another one. Hopefully the next video will be my last video, and we're going to solve this problem. But in the meantime, while I'm stopping this, you could try to solve this problem, see what you can do with it, and but we'll come back shortly and we'll talk about it.